we're getting let's get going. So yeah, thanks a lot for joining. And today we're going to talk about our application observability using Sumo Logic. And basically, there's a couple of things I want to touch on there with that. So basically talk about that, kind of what that means within kind of Sumo, and effectively show you a couple of examples of how to do quick and effective troubleshooting, being able to kind of look at the different entities like service maps and traces and spans, but also the kind of interjection into like how your logs is associated or correlated with these things. And also, given that we're looking at applications and sort of modern type applications, which basically means microservices type, we also want to show you something that we've recently sort of released, which is the global intelligence for Kubernetes. So that's going to kind of give you some sort of indicate or some help in how you can kind of configure and manage your Kubernetes configurations. So with that in mind, you know, observability really kind of requires a lot more data than just monitoring and just kind of like, it all depends on what you want to do with the data you're looking at, as in the machine data. But of course, typically what you want to be able to do is observe how your systems and how your sort of applications and services are effectively being provided to your customers. Now, to monitor that, it's a question of looking at sort of, you know, looking at the dashboard, kind of effectively seeing your metrics coming in, seeing what's happening within your environment. And you know, you don't necessarily need all the data there. You can do quite a lot, you can understand quite a lot by just looking at a lot of metrics. Now, to diagnose something, you need to kind of dive deeper into it. You need to have more context around what's happening, where is it happening, you know, what kind of problem is happening where. For that, you typically need a lot more data. And to be able to effectively do troubleshooting, you're going to need sort of all the data you can think of, right? Because now you really want to understand why is this happening, and not just the kind of symptom that you're seeing, but also the root cause of what is kind of the real cause of all this. So the more you're going to dig deeper into this, the more data you want to have, and probably the more complicated it's going to be as well, right? You need to have skills, you need to kind of be able to investigate properly, and you know, systems that support you in doing this. So that's really what we're trying to show you and what we're trying to do here at Sumo. Because this is kind of really what we're aiming at. Doing certain things of this is pretty easy, but doing all of this is kind of where you need to have, or where you will be benefited by having all the data in one single place, being able to correlate the different data sources, and also kind of really be able to slice and dice the data in whichever way kind of suits you for that specific use case. So with that said, you know, Sumo is all about sort of collecting various, you know, multiple sources of machine data, and effectively any text-based data can be pushed into Sumo. We're of course very focused on the cloud providers and the new type of applications, but all your on-prem systems can sort of send the data into Sumo as well. What we're seeing is a big take-up on the DevOps tool chain and the kind of cloud services. So not just the cloud providers, but also things like Okta being provided as a service, or your kind of Atlassian products like Jira or Opsgenie and all these kind of things. They more and more provided as a cloud service. So you need to have that too, right? And it's a mixture. Some of these things you need them for operations. Some of these things you need them because of security. But the beauty is that once you get into Sumo, you can really look at it from both different ways, right? You may have some people looking at this from a security perspective, and some people are going to look at it from an observability or operations perspective. So today we're talking more about the observability, but this kind of, you know, having all that data in there just makes it very simple. And with that said, you know, it's kind of, you have all these dashboards and out of the box content. You know, dashboards are great. The problem with dashboards is that once you get a big estate, there's going to be many, many dashboards to go through. So even if you have some kind of folder structure, how are you handling all this? But we got a solution for that too. And of course, we want to try to apply as much analytics into this so that you don't have to do that. Automatically detect anomalies and outliers, using machine learning to kind of drive a better way to kind of sift through all that data, being able to find the needle in the haystack with something like log reduce. But also, as I said, the global intelligence, it's really kind of a benchmarking optimization solution for a vast number of different data sources. So we're going to look at it from a Kubernetes perspective. But really, this can be applied to many different other data sources as well. So with that in mind, let me jump into the demo. And the demo today, we could start with the alert in Slack, but for simplifications, because I've been changing a lot of these things, and I don't necessarily have all the admin rights into our Slack environment. So therefore, I'll just send myself an email here. And in this case, I'm looking for an outlier. It's a coffee bar application. So you can effectively, you get a website, you can go and order some different coffees, and we then kind of monitoring this from the back end here. So here's basically my sort of monitoring query that we're running. And in this case, we're looking at sort of service latency there. And we're looking for any service within the coffee bar application. And of course, there's multiple different services in there, so it could be anything. But in this case, we've now sort of received a sort of latency alert here. So what I can do with this, I could sort of go straight into playbook. That's going to take me to the application and to wherever that is coming from. But at the same time, I can add sort of more content in here. So I can have an application overview dashboard where I can just go in and look at the application, maybe more like a business overview or something like that. So kind of, basically looking at visitors over time, which have dropped quite severely here, and also looking at where a customer is coming from, what kind of device are they using, or things like that. I could have a lot of information, just ordinary text information. So like, who's the application owner, the Kubernetes lead, and infrastructure owner, and stuff like that. But then maybe more the interesting aspects is more like, okay, how many bookings per hour am I getting? And this is kind of for the last 24 hours. So roughly we're seeing like 3,000 bookings per hour. Not sure, that almost sounds like a Starbucks or something like that, but yeah, it's all synthetic, of course. And then you can see the booking split here. So effectively, espressos, Americanos, and cappuccinos. Not that much, but for the last 15 minutes, we get a bit more kind of split up into like, okay, one Americano, one sort of espresso, and so on. Now, maybe the more interesting thing is if any orders are failing, and in that case, why are they failing? So orders over time, sadly, I must say, I don't have any failures here. And you can also see this because what we can do is calculate this by a dollar value. And right now, there's no orders failed. So therefore, I'm not kind of, otherwise you would effectively have a spike, or you would be able to see how many dollars you're losing by minute or by hour or whatever it may be. What I can see though is that I got some latency, and it's been kind of spiking up and down here for the last kind of minutes here, right? And I can also see some other order outliers here. This is not necessarily a problem, but it just shows me that the amount of orders are fluctuating, which basically correlates with the visitors over time. So this kind of just gives me an overview. Now let's kind of look at the more details of it. And I mean, as I said, this is a Kubernetes cluster that has kind of the deployment here runs within the namespace called Coffee Bar NS. And basically here's the application running within a Kubernetes cluster here. So I have a complete sort of separate Kubernetes cluster for supporting this application. Most of these things is pretty okay, for the last 15 minutes, as in from a resource perspective, it's pretty okay. Not sure what this is all about. I got some issues here with regards to memory. Sadly, it's a demo moment. I didn't have this like 30 minutes ago. But anyways, I can see sort of a lot of details here with regards to my application and with regard to the infrastructure and my application. So not necessarily the application per se. So this gives me a good overview of what's happening in the cluster. Now, what we've added to this for the last kind of couple of months or half year or so is basically you can also then look at it from an application service view. And there's actually multiple different views here. If this cluster is running in AWS, I can actually look at it from that perspective as well. But in this case, I'm going to jump into the application service view and also look at the coffee bar application. So here's basically my coffee bar application, and I look at the health across all the different services. I can see sort of different aspects of latency here, but then I can see down here as well. And as you can see here, there is this blue bar, sorry, this red kind of part of the bars is basically the coffee bar front end. And I also saw that no, sorry, it wasn't, yeah. So here's the coffee bar front end. Doesn't look too bad when you look at it from that perspective, but and I can also see some error percentages. So the machine service have had a lot of problems there. The latencies are going up and down, but you know, I got some spikes here, so this is kind of interesting. But basically, yeah, so I can kind of see more details about the application. Now, if I want to, I can dig into, for example, the machine service. So you saw that I had a lot of elevated errors there, right? So I can see that here as well. And here's basically one of the kind of latencies that's been going up here. So it gives me a lot of details. And of course, I could go into other kind of dashboards as well. I can actually look at this from a real user monitoring perspective as well. Now, that's not going to be that great for just the machine service. So let me step back here and come up to the coffee bar. We can then look at the overview for run, which basically is going to kind of show me the page load and the requests. But it also going to show me things like the top browser by requests, the top operating system, so a headless Chrome device and a Linux box, and basically come out of the US. I can see the website performance, and I can also see the UI paint timings in it. So this really gives me a good indicator of, is this kind of related to the back end or the front end? And how is my customers, you know, experiencing the service, right? So there's a lot of good things there. Now, as I said, I wanted to kind of take you through a couple of different ones, and this is not necessarily a perfect way of how you would investigate things, but it's just that I want to kind of show you all the different things we've been adding to this as well, right? So a different way to look at this application is actually to look at a service map. So we would investigate, or having that tracing data coming into Sumo, we would effectively automatically create this service map. In my case, I'm only interested in the coffee app, so I can kind of take that here. I could sort of hide remote services as well, or effectively remote services are things like a database that we don't necessarily instrument, but we can still see it because we got connections here, right? So we refer to that database, and that's why it looks like a cloud as well. I can also influence the way I want to detect sort of anomaly detection in here. So right now I got sort of an automatic anomaly detection here, which basically looking at this and looking at an outlier from outlier of threshold of 4. But I could sort of inflict whatever I'm looking at here on my own, right? So you saw that some of these things are kind of popping up here a bit more kind of red because I effectively added the manual anomaly detection. Now, that's all good and well. What you can see also here is that basically some of these services are showing red. So when I hover my mouse over it, you can see that there's anomalies here that basically has increased latency, and it kind of been going on for some time. So For the last kind of 15 minutes here, I got some latency and KPI anomalies. You saw that we had some issues with the machine service, so therefore I got some things there as well. Now, that's good, but it's not the only thing we can do. So I can just click on the machine service and I'll come into that service. I'll see that this is service that's part of the coffee application. So I could sort of delve into the coffee application, but in this case, I want to take a deeper look into the machine service. So I can do that. And the beauty with this is that I can go back into the Explorer view and kind of see where this is related. I can look at the logs for this service and remember that we collect the logs continuously. We store them in Sumo. So even if this microservice or even if this container is gone, we still have the logs here. So just pivoting in there and kind of looking at the log search for it, I'll see all the logs for this service. And then it's a question of what I want to do with it. Likewise with metrics, and with metrics, I can also use a root cause explorer. Root cause explorer is actually a different thing of how we identify outliers with regards to metrics. But in this case, I'm interested in the traces for it because something is going on with this application. So what I can do then, and taking that context of timings and the application and the service that you show or that you saw, I also want to add sort of some filtering to it to basically say that I'm only interested in spans or traces that includes an error within it. So I can kind of see here, just going down this list, I can also see this kind of mouse over capability, but I'll just basically take this kind of span here, right? Or sorry, trace. So I got my complete trace here. It's basically the complete path of from when my customer was looking at the website all the way to when they order it, and hopefully when they get this order. I can see that, you know, these are all related because these are basically the kind of coffee machine. So here's basically the click that's happening on the browser side. Then we come into the application, but we also have some additional applications here associated with this that takes place. So basically, you know, my coffee machine is here, ordering sweets and getting the sweets packed up. That's kind of added here. But what I also can see here is that some of these traces have this kind of overlaid red line. And that is because there's an arrow there. Now, if I hide away the kind of all the other coloring here, I can actually delve into this. And what's happening here is really that this is failing, and that kind of makes the next span fail, the next span fail. So it's a bit like, you know, I see all these spans are failing, but in essence, it's most likely that it's this water service that actually inflicts the kind of other spans to kind of show a failure. Now, of course, I want to dig deeper into this, and I can do that. Just clicking at it, I can get the information about the water service. You know, obviously it's getting water here. It has a status of 503. I can see a lot more metadata, both with regard to the application. So it's a Ruby app running here, but it also runs within the Kubernetes environment, and it also has all the metadata that Sumo adds to it. And this is just some of that data, to be honest. As you saw before, I can see where I am in the context of the application. So this water service is an operation within, this operation is a part of the water service, that's part of the application that runs within this container, which is within this pod and so on. So you get it. Now, I, of course, want to investigate this. And the easiest way to do that is to kind of just look at spans. I can look at the trace or spans that is associated to this specific service. So the beauty with Sumo is that when we start to collect the data from the Kubernetes cluster, including the tracing data, we can also tag all the log lines with the trace and the span ID. This really means that for any log line that goes into Sumo, we know exactly where it's running. And this is beautiful because now I got this service running within this time frame and it's failing. You know, instead of trying to sift through all the different logs that, you know, you could, yes, you could go into that kind of pod and the container, you would still have a lot of different services running there maybe. What I can do here is I've identified the span that is failing. I can now just say, like, I want to look at the log lines that's associated with that span ID. And this just takes me in, and it's a very simple search query, to be honest, because I'm just looking for the span ID. And here I see the reason why this is failing, the reason why I can't sort of deliver the coffee is that there's not enough water in the machine. So a very simple solution is, of course, to add some water to it. But the beauty with all this, and I know it's a bit of daft kind of, very simplified way of your service, but it is kind of very conceptually easy to understand, right? You're not having whatever resource you have, therefore you need to add that. Being able to see this in the kind of traces and being able to follow those traces through. So effectively, we looked at this. We saw some sort of latency. We saw some error messages. We went in to look at the traces for those error messages, and we basically could pivot over into look at the logs for those. So that's just the beauty of kind of using Sumo in that sense, because we really can kind of have you to be able to look at things in a different way. Now, I want to show you something else, because Sumo's been all about doing searches and looking at logs and all that. Spans don't necessarily capture or holds that much of kind of language in them, so to speak. But that is depending on the developer. So you could sort of say, like, this operation is going to output some more data to it and so on. And we see that there's a lot of customers out there who's actually looking at this. So what you're able to do with Sumo as well is to actually do searches on a span. And as I said, it all depends on what you're looking at. But if we take, for example, a service here, and I want to take a service that basically is the, let's take the cache desk. I then want to look at the duration of this, and I want to see the average. I want to group this by time, and I want to make it 1 minute. And then I also want to look at it from a status code perspective. And I'll do that for the last 50 minutes. So the beauty with this is that this is almost like the search language in Sumo. And in fact, it is the search language in Sumo. You'll see in a second. So here's basically the different sort of durations, the different status codes divided by the operation, and we're looking at the cache desk. You see the span IDs and all these kind of things, and you also see it here, right? Now, if I want to look at the aggregated view of this, you can kind of just see this. And of course, you can change this from being a bar to maybe doing a column chart or something like that instead. And maybe you want to do that for the last hour or so. So effectively, now you're looking at kind of the status code of 400 and 200s here. And you can see that, it's been a bit of a spike with regards to 402s. So this is just kind of looking at it from status code and duration of it. But the beauty is that you can kind of do a search in spans. Now, if I really want to make this useful, I may want to combine this with some log data as well. And in that case, I can just, maybe I did that too quickly. I can actually open up this in a normal search window. So just clicking here will open up this, and here you get the kind of query that's already been done for me based on what I did in the kind of basic user interface there. So if I'm skilled up enough, I can just go and type this query or kind of look at it from that perspective, because this is just a normal search. The trace data is slightly, doesn't necessarily have sort of log messages, but effectively, if it had, I could do searches for that as well. So the beauty here is that I can really kind of look at this from many different ways. I can combine different data sources, and I can really kind of dig deep down into the application and kind of find root causes and different sort of kind of anomalies. So just checking if there's any questions. So if you have any questions, please just put them in the chat window there. But basically, that's kind of what I wanted to show you. I've got a couple of more things, but before we do that, I want to come back to the slides here. So the global intelligence for Kubernetes really means that we are looking at anonymized data and are able to help you to overcome certain sort of, guide problems where you need some guidance or benchmarking on things like that, right? One of those things that we've seen is that when you deploy a Kubernetes environment with a lot of containers and pods and all these kind of things, one of the requirements there is that you need to kind of define your requests and your limits. Effectively, how much resources can be used by this kind of pod or these containers, what are the soft limits, as in the requests, and what are the hard limits, as in what are the limits. This typically means that you need to say that this pod is going to be using, 2 gigs of memory and 10% of CPU. We'll kind of look after this, and actually what's going to happen is that if you're trying to use more than what your limits are allowing you, it's actually going to kill it and restart it, which means that you're not going to have a service outage or anything like that, but you're going to have a pod that maybe goes up and down. This is constantly trying to allocate more memory or CPU than what it's supposed to. So the risk here is that you will get an out of memory termination. Or the alternative is that you're not going to be using your resources as much as you thought. And of course, the problem here, and looking at this, there's a lot of there's a lot of configurations here that's not optimal. So what we're trying to help you with here is to have a balanced view of this. You can have it based on a reliably optimized or cost optimized, and different ways of doing that, right? So let me take you back in here to the Sumo interface, and what I want to show you. So for my cluster here, I got this application. It's just called Global Intelligence for Kubernetes DevOps. It's actually telling you a lot of what we're trying to do here, and it explains what the risk percent and what the slack and all these kind of things are. But just very briefly said, here we're looking at all the clusters within my environment. So in this case, I'm going to select the kind of coffee app cluster. It seems to be pretty okay if I trust that all the data is actually in well used, but I can also play around with this, and of course, let's look at the actually I have the clicker service, and then let's say that only 10% of the data is actually or 10% of the data is actually containers being ephemeral. So with this configuration, I can see that there's a risk for sort of memory risk percentage is fairly high. The slack is pretty okay. The memory is pretty okay. The CPU is also quite sort of in danger, which basically means that there's a risk for that my sort of configuration is not optimal. Now, it's good and well to say that you are under risk for it, but of course we want to help you. So if we do the optimization plan for the memory of this, I can come in here and I can do the same thing. So let me look at the clicker. Just to be consistent, I'm going to select 10% again. And in that case, today I'm using 536 megs for that sort of for the containers being deployed within this pod. And Sumo is actually suggesting that we should be using 900 megs. And then we have this delta here, basically on, oops, there's a delta, 62%. So it actually not easy kind of showing me this as a nice graph. It actually gives me the exact numbers down here as well, right? And this was with regards to the requests, but I also have, from a limit perspective, I'm not too bad. I could actually lower the limit somewhat, but it's just to be able to have the request there. So I'm sort of more in sync with what I'm actually using. So this is just kind of trying to show you that, you know, we can help you not just to find problems and everything, but we can also help you with regards to things like configuration of it. Because to be honest, in many cases, the configuration of a Kubernetes environment is not necessarily always that simple, right? So with that said, this is kind of one of the things. And of course, I could do the same for CPU here. Container time series, there's a lot of other things. I can also look at the adoption rates. You know, this is more of a benchmarking, as to say, like, okay, normally customers like you, you know, the GIS benchmark here is kind of typically running on a 3.57 or 3.5 clusters per cluster count. So yeah, per customer. In my case, I've actually got 3. Deployment, so effectively the number of deployments within these clusters, I actually have a few more than what normally customers using Sumo would have. So it's just different ways to kind of compare and all that. So there's a lot of different good uses for that. So with that said, I'm open for any questions if you have any. So feel free to add that. And in the meantime, I just also want to highlight that there's a Sumo user conference or Sumo Logic user conference called Illuminate that's taking place at the end of this month. So if you go to sumologic.com, and we got the link here as well in the chat, you can register for it. The beauty with this is that this is really going to be kind of Sumo customers talking about how they're using Sumo. So if you want to kind of, you know, listen to peers in the industry, then that's a great place to do that. There's of course going to be a lot of information from our engineering and product management teams as well, but, you know, there's mainly kind of customers talking about how they use Sumo. And the last thing I wanted to kind of give you as well is basically this kind of link. You know, you have the link in the chat window, but basically sumologic.com, and kind of click at the what is it, right top hand, where you can start your free trial with Sumo. So with that said, I don't see any questions here, but yeah. So with that said, I want to thank you for the time today. I hope it's been valuable. And you know, let me know or speak to any of my colleagues within Sumo Logic. We're here to help you. So thanks a lot.